Software testing is an important part of software development and maintenance. It is a process that can be applied to any system, product, or service where the goal is to detect bugs before they are released into the world. Software testing includes static testing or checking for errors in the code, dynamic testing by executing programs, alpha beta testing where the users test the pre-release version of the software, and many other types of testing. There are 7 principles of software testing that can provide a framework for quality assurance. These principles are important for any tester to know and understand. Number 1. Testing shows the presence of defects, not their absence. Reducing the chance of hidden flaws isn't proof of perfection, but testing does reduce the possibility of new flaws. For example, a test for the password requirements of a login system would check that the requirements are met. If the requirements are not met, it will return an error. The tester can then investigate and determine if there's a problem with the code or if the requirements were incorrect. However, if the problems are resolved, this still doesn't guarantee the prevention of future errors. A new requirement might be added that wasn't originally considered, or a change in technology could create new opportunities for errors. Number 2, exhaustive testing is impossible. It is impossible to test every input, output, condition, and decision for every program. Instead, testers must select representative samples. For example, for a form input designed to only accept ages 15 to 80, a tester could enter the values 14, 15, 80, and 81 to test the boundary conditions. On the other hand, if the select element provides 2 choices, true or false, the tester could test both values. Number 3, early testing saves time and money. It's cheaper to fix errors when they are first introduced into the code. The later an error is found, the more expensive it is to fix. For example, if a bug is fixed during the design phase, it may only require a change in the code. However, if the same bug is found during testing after the code completion, then it may require changes to the code, documentation, and user interface. The result is increased time and effort to resolve the issues. Number 4, defects cluster together. Bugs tend to cluster together in certain areas of the code. The Pareto effect, 80-20, states that a small number of modules, 20%, usually contain 80% of the defects. Therefore, testers should focus their attention on these areas to find the most defects. For example, if a tester is testing a login system where the team knows that the authentication module is prone to frequent errors, they should put their efforts into testing that part of the module, since this is where most of the defects are likely to be found. Number 5. Beware of pesticide paradox. The pesticide paradox is the observation that the more you use a pesticide, the more resistant pests become to it. The same is true for software testing. The more you test, the more resistant defects become to detection. The reason why is because if the same tests are done over and over again, they will no longer discover any new problems. To overcome this, testers must constantly adapt their testing techniques. Number 6, testing is context dependent. The context in which a system is used affects the way it should be tested. For example, a system that is designed for use in a hospital will need to be tested differently than a system that is designed for use in a bank. The hospital system will need to be tested for things like patient safety and data privacy. The banking system will need to be tested for things like security and fraud prevention. Therefore, it's important to consider the context which a system will be used when determining how to effectively test it. Number 7, absence of error is a fallacy. The goal of software testing is to find as many errors as possible so they can be fixed before release. However, it's impossible to find all the errors. There will always be some defects that will remain undetected. It can be a misconception to believe that the success of the system can be guaranteed by finding and correcting a large number of faults. For example, a system with no faults may still be unusable if it does not meet the needs of the user. A real-life example is the failure of Google Plus to compete with Facebook. Google Plus had no major security flaws, but it wasn't successful because it didn't meet the needs of the users. So, the 7 principles of software testing provide a framework for quality assurance. They are important for any tester to know and understand. By following these principles, testers can find and fix defects before they are released into the world.